Hi, I'm Paul Battaglia, and this is section 10.4. I have Gabe and Brittany with me here today, and we're going to start off by talking about lines in space. So Brittany, take it away.
All right, so when we were talking about lines in 2 dimensions, we were able to find the slope and then get an equation for the line. Okay. Well, now that we've added another dimension to this, we are unable to do this. So now, how do we do this?
Right.
We can use parametric equations or symmetric equations.
Okay.
And one thing that I like to point out to my students is we can only use symmetric equations when we don't have a 0 as one of the directions.
Oh, got it. Okay, perfect. Good. And I think once we get from lines in space and we make that transition now to planes in space, I think it's important that students visualize correctly, right? So what I've actually found helpful is, if it's a nice day and we can go outside, I might take the class outside. If not, then I have to make some room in the classroom, maybe lay a blanket down. What I'll do is I'll try and recreate the 3-dimensional coordinate system. So I'll have some students lay down and form the x-axis and the y-axis, and then right where they meet, I'll have a student stand up and they create the z-axis. And then what I'll do is I'll take some type of a flat object. I would tell them maybe in class, imagine this is a solar panel, but maybe I'll take a piece of paper, or maybe I'll take something else, and I'll kind of lay it kind of on a slant, and I'll say, now this is what it means to have a plane in space, And I think that actually gets us ready, Gabe, then to talk about the intersection of these planes. So
sure.
Talk to us about that.
So in 2 dimensions, we have 2 lines intersecting,
right,
and that forms a point. But in 3 dimensions, well, if we're talking about planes,
right,
they're not just going to intersect at one point.
Correct.
There's actually going to form a line
right,
of intersection.
Right.
And the book doesn't discuss it much, but it might be worth mentioning that when you're talking about 2 planes intersecting, well, you don't just have the one case where they do intersect and you get a line.
Right.
You could have the case where these 2 planes never intersect.
Correct, right.
And it's not necessarily calling them parallel, but it's sort of the same idea. You can have 2 planes which don't intersect. Or you could be given 2 planes which lie on top of each other, which are the same plane.
Right,
so you don't have a line of intersection, you kind of have a plane of intersection.
Right. Perfect things to point out for your students. And I think a good way maybe to bring it all together and end the lesson is with a neat little activity here. And so I have what we call tapered bread pan. And if you don't have this available, they're pretty common, but if you don't have this available to you, perhaps you have a tapered wastebasket. And I think the reason I'm really highlighting the tapered idea is because what we're really looking to do in the end is have students actually find the angle between 2 planes on this pan. So here's kind of how I motivate it. First off, I say, all right, let's imagine that we put this in the 3-dimensional coordinate system. And I'll pick one of these vertices of the pan to be 0, 0, 0, okay? When I do that, then we may even measure some distances along the pan, and then I'll ask them to go ahead and use what they've learned to find the angle between 2 planes. But right before I have them do it, what I'll tell them is, the reason that we use this math, guys, is because if I asked you to find this angle and just gave you a protractor, you'd have a little bit of a problem,
Yep.
And the only way that you can maybe even recreate this is to get a bunch of different paper out, I guess, and try and reform this. But let's deal with what we have. This is real life. This is the pan we have, and so let's try and model it after what we've learned, and try and put all that into good use. So I hope these tips have been helpful for you, and you find much success in section 10.4.